Hello and welcome to another tutorial. We're going to continue our discussion on nested classes. So the Java programming language allows you to define a class within another class, and basically Java allows you to define a class in any scope. And we said that the only scope that is allowed is either in the source file as at the global scope of the source file, or inside the scope of another class. And later you see even in the scope of a method, you can define another class, which is called the method local inner class. All right. Such a class is called a nested class, and it's also sometimes called the inner class or nested inner class. So as long as they're not static, it means they're just nested classes, or inner non-static inner classes or nested inner classes. These are all the same terminologies that we use for this kind of definition. So you see there is an illustration here that we have a class, outer class, and we said that if you define the class inside the scope of the another class, this class that is defined inside is called nested class or inner class or nested inner class. And then the class that the other it encompasses or encloses the other definition is called outer class. And this is a very common terminology, so please get used to it. Outer class, inner class, or nested inner class, or inner nested class. These are all the same things. Terminology. Nested classes are divided into two categories, non-static and static. And the other thing is that so we can define a static modifier on this class definition, and we saw that this is not allowed when you put the class definition in the global scope, right? You cannot go to the class that is defined in the global scope of the source code and say a static, for example. This is not allowed. It's going to give you a compilation error. And let's look at the error. Illegal modifier for class, this only public, abstract, and final are permitted. So when the class definition is in the global scope of your source file, only public, abstract, and final modifiers are permitted, which makes sense. And we have looked at this before. So public means we are opening up this class to everybody, and we said that in the global scope of the source file there can only be one public if you choose to make it public class, and then the name of that public class has to match the name of the source file. That's the restriction from the Java language itself. Abstract, we've looked at this. For example, interfaces by default have the abstract keyword implicitly in their definition, even if you don't have a explicit word abstract, then interfaces are always abstract. So we can change this class to interface, right? And then now this becomes an abstract by default. So interfaces, you can say abstract interface, doesn't matter, it doesn't change anything. Abstract is implicitly added. And then interfaces can also be public or package level, right? And right now it gives me an error because if something is public, even an interface, the name has to match the name of the source file, right? That's the compilation I get. The public type, my class 2 must be defined in its own file. Why? Because the name of the file, Java source file, must match the name of the public type. And you know that even the compiler is using the terminology type instead of class, right? Because interfaces, classes, enums, these are all types, and Java is based on a static type system. So let's set it back to class. Final means we make sure that we don't want anybody to inherit from this. So nobody can inherit from this class, because nobody can override anything about this class. So you cannot inherit from this class. If you make a class but don't make it final, but basically make its constructor private, we have to provide even an empty body, that's fine. So again, nobody can inherit from this class even though it's not final. Why? Because if somebody wants to inherit from this class, and this class only has one constructor which is private, so if somebody wants to inherit from this, we've seen that in their constructor the first line of code is the call to the superclass constructor. But if the superclass constructor is private, nobody can access it. Private means literally nobody can access it outside this pair of curly braces. So if a class, all the constructors are private, nobody can inherit from them. So it becomes like a final class, but it has more restriction because not only nobody can inherit from it, but nobody can even instantiate this class because it has a private constructor. If you want to create an instance of this class, you have to be able to call the constructor using the new operator, right? However, final has less restriction because you can have public constructor in a final class. Still, nobody can inherit from this, but people can call the superclass constructor. Basically, people can call the constructor and create a new instance of this object, right? So final has less restriction than having private constructors. All right, so going back here, so non-static nested classes are called inner classes or nested inner classes. Nested classes that are declared static are called static nested classes. So in the inner classes, we saw that you can add the modifier static, right? So we can have a non-static inner class or a static nested class or a static inner class. The difference is how they behave. And so far in the previous lecture, we look at the example where this battery class was inside this public class nested, right? And we saw we didn't declare a static here. So this is a non-static class or non-static inner class or non-static nested inner class. So let's type this here. This is a non-static inner class. And we saw that the main benefit is that a non-static inner class can access all the non-static and static states of the outer class by default. There is no restriction here. So you see this model, this variable model was actually a variable or a field of the outer class, which is field means it's part of the state, and in the declaration of the class we were able to use it without even creating a new instance of this class. And we saw that this was the benefit, because if you put that battery class outside the scope of the class, this becomes a class by itself. So if we want to, every battery depends on the car model, it should either hold a reference to the car object or have some other variable in its constructor so that it has the information as to what car model is being created. And we said this is the benefit of a non-static inner class, because it already has access to the fields of the outer class. So it already has access to the information about the state of this class. So if somebody calls the constructor of the outer class, the job of the constructor is to basically construct the outer class, which means initialize the state. Therefore, the state is initialized, and if somebody calls the constructor of the inner class, because the state of the outer class is initialized, it's fine. Now note that there is a catch here, and the catch is that we know that the default value for this model, which is of object type or reference type, is null, right? So if somebody passes a string model here, if before initializing this model we call the constructor of the battery, this still works. We don't get a compilation error. But when we go and call the constructor of the inner class, this model at this point is null, because this reference string hasn't been initialized, right? So you have to be careful that the state of the outer class is initialized first. That's your job as a developer, and then therefore the inner class has access to the initialized state of the outer class. So if I go and run this, we get a null pointer exception. It says that you're switching on the null, and we saw that previously you can switch on the string types, which are reference types, because strings are final, unmodifiable. And we saw that in the lecture about the switch statement, or the switch expression. The way it works is that it actually replaces this line with the hash code. Basically, it switches on an integer. That integer is the hash code of the string, right? Because param.model is null. So it says that your model field, which was the outer class, and this inner class can access it, is still null. It hasn't been initialized. So be careful that be careful. So be careful to initialize the state of the outer class before calling the constructor of the inner class, right? Usually when you have inner class, at some point you want to create an instance of it, even though your public API doesn't expose this inner class to the user, right? So let's go back. So be careful about this before calling the constructor of the inner class. So you have to be careful that the state of the outer class is initialized first. We know that integers get their default value 0. Reference types get their default type, which is null, right? So I'm going to write this object reference type, a variable of type reference or pointer. The default value is null. Default value is null. So a nested class is a member of its enclosing class. When we say member, it doesn't mean it's a field. It's not a field. It just means it is accessible in the scope, right? So obviously somebody in another method can directly create an instance of this inner class. Non-static nested classes or inner classes have access to the other members of the enclosing class, which means they have access to the fields and also methods, right? So let's write here. We have this get model, and in the constructor of the inner class, instead of model, can we say get model? Yes, it is accessible for us. So not only we have access to the fields of the outer class, we also have access to the methods. Now the nice thing about having access to method is that then in the constructor, you make sure that you initialize all the fields, you initialize the state, and then if somebody calls this get model, you are pretty much sure that the model has been initialized. But if you pass the field itself, and then you're not careful, you try to call the constructor of the inner class before initializing this model, then that could result in the null pointer exception as we had here, right? But if you just call the get model method, for example, then you are sure that if somebody is calling this method, which is a non-static, then the state of the object has been initialized. So this model variable has been initialized if the code is logically sound and it's written well. So that's the whole idea of nested, non-static nested classes. They have immediately access to the state and the fields methods of the outer class, even if they are declared private, because this class is literally defined in the scope of the outer class. So it should be able to access everything. Static nested classes do not have access to other members of the enclosing class unless it's a static state, right? A static field. So the difference here is that if you declare an inner class static, all you're saying that basically a static inner class is not much that different from a freestanding class definition. The only difference here is that sometimes, first of all, putting a definition of the class in another class creates a kind of like a namespace or package like. So you cannot access this type directly unless you have access to the outer type first. So one is more restricted access to the type. So for example, I can have a static class wheel, for example, right? And then the wheel has int price, for example. So right now, and then we can have a public constructor, public wheel, and then int price, and then we just say this dot price equals price, right? Now, why do we put this wheel definition, first of all, inside the nested, inside this class, which was representing our car? That's because it makes sense, right? Every car can have a wheel. So maybe, and therefore, if somebody wants to create a wheel, they can. So for the non-static inner class, we saw that there was a weird symbol, right? You have to create a variable, first call the new operator on the other class and fully create an object and initialize it, and then call the dot new. So this is not just the new operator, this is the dot new operator, which means this is, remember, dot means we are accessing the state of this variable, this object. So dot new means we are calling the new operator to create a class which is via the state of this variable or this object. Now last time I used var, so we didn't look at the type, but what is this type? We said that we cannot just, for the non-static inner class, we cannot call the new operator on the type outer class dot inner class. That's how you access the type. But then we said we cannot do this because this is independent of the state. So you have to have a fully initialized object of the outer class first, and then initialize the call the new operator on the constructor of the inner class. So the type here, obviously car is a variable, so car is not the type of this b1, right? So the question is, when we do dot new operator, what is the type here? And the type is actually the type that we already knew, right? It's the outer class dot inner class. So nested class dot battery. This is the type. And because now you see that this battery type is enclosed in the state of this class, in this type, right? So this is adds more level of modularity. So we have packages and any type is inside the package. And then this battery type is not freestanding by itself. You have to access it via the outer type, which is in this case this nested class that is representing our car. So in these cases it's much easier to use var, okay? But then remember that the type of the variable, when you call the dot new operator on the constructor of the inner class, it returns the type, which is outer class dot inner class. So outer class, I'm going to say type dot inner class type. And we can actually remove this class and say outer type dot inner type. That's the type of this variable, but you cannot call the new operator on this type, because we saw that the way the new operator works is you have access to the type first, and then you call the new operator on the type, and then pass parentheses, right? Pass some parameters with the round brackets, and then the JVM knows which constructor to call based on the number of parameters and the type and the order, etc. So new, you call the new on the type, but then you pass the parameters so that a JVM also creates the object and initialize it. So new on the type so that JVM knows which type you're talking about. But in this case, we use the dot new operator. Dot new is different from new. Dot new means, hey, use this constructor, and obviously it's associated with the state of this particular variable. So JVM knows the type of this variable, which is our outer class type, so there's no problem. But then the question, when we do this, what's the type? And we know that even if you could do new nested class dot battery, obviously the type is exactly the same as here, right? So the type, if this was possible, the type is exactly what type that we are calling the new whenever you call the new operator on a type, it returns exactly the same type, right? That's the whole idea. So here, when we call the dot new operator, it also returns the type, which is outer class or outer type dot inner class or inner type, right? Now for the static inner class, you probably can guess what happens. It's exactly like this. So var b2 or wheel w1 is new wheel. Now we don't have access to the wheel, right? And then the question is, what do? We say the outer class nested class dot wheel. Now we have access to it, and price, let's say 100, right? Now what does happen here? So what happens here is that you see, now we are calling the new on the type itself. We didn't need to create a instance of the outer class first and initialize the state and then could use the dot new operator, right? So let me write this here, this dot new operator instead of new operator. So when you say dot, it means you are accessing the state of this variable, which is the object. And dot new means we are using the new operator to create an inner class which has to be associated with the state of this variable or this object. But then for the basically static inner classes, you don't have to do it. There is no static inner classes because they're static, and static means it's really not associated with the state of the particular object, right? So you don't need to create an object of the outer class first and then call the new operator, right? So you shouldn't do it. You just directly call the type. So it's just like creating a hierarchy of the types, a type inside another type. That's the main use case of the static inner classes. Sometimes it makes sense that this wheel has to be inside a car class, because then you say car.wheel. Or maybe you could create a package called car and then car.wheel. That's still the fully qualified name of this static class, right? So the fully qualified name of this static inner class is, let's also say this, the fully qualified name of the static inner class is basically all the package of the outer class, the fully qualified name of the outer class. All right, and then the fully qualified name of the outer class is its package, and then the name, and then dot inner class wheel, right? Now later on you see that this is actually not true. This is not true. This is not true. The fully qualified name that is written, this is the logical representation, but it's actually what happens? The correct fully qualified name is outer class $inner class. So this is the fully qualified name. Remember what the fully qualified name is. So when basically when the JVM compiles this class, we know that every class has to be compiled to a separate class file. Every class definition, this static inner class will get compiled to a separate class file. The question is it going to be like wheel.class? And the answer is no, because then JVM has to differentiate somehow, or the compiler has to differentiate somehow between, or JVM, it's more for the JVM. So the compiler has to somehow give the hint to the JVM, this wheel class is not a freestanding class by itself, right? Because if you just say wheel.class, it means it's a fully freestanding name. So the way the compiler handles this, it says that outer class name $inner class. That's the name of the class file that gets compiled. So we can go ahead and so you see we have two classes here, and this dollar notation also applies to non-static inner classes. So outer class $inner class, when JVM goes and tries to look for a type like wheel or battery, it sees that, hey, it's always outer class .inner class. So it realizes that this has to be a inner class, and the notation is outer class name $inner class. So when you see dollar outer some name some other name, it means it immediately tells you that these are inner classes. Battery and wheel are classes defined inside the scope of this outer class, nested class, right? So same with the with this our battery class, and it doesn't matter if these classes are public, private, whatever. The naming of the inner class, the class file name is always outer class $inner class, right? This way the compiler gives the JVM the hint that, hey, this battery type, which is a type by itself, cannot be accessed directly. It has to be accessed via the type, the outer type, or its parent class, or its enclosing type, which is the outer class. In this case, called nested class. All right. So in the source file, if we want to access the type, we say outer class .inner class, but the name of the class file is outer class $inner class, and then the fully qualified name is package outer class $inner class. And then let's open up this, for example, a static one, and let's see what the name of the type is. We know that the fully qualified name of the type is the one that is written in the bytecode. That's what JVM understands. JVM doesn't understand nested outer class .inner class. It just looks at the bytecode, and in the bytecode it's nested class, which is our outer class $inner class, right? And this is the constructor, and then here's the fully qualified name. It's the package hierarchy, basically the fully qualified name of the outer class, and then $inner class. This is what JVM understands. So whenever you say wheel, what JVM actually understands, the package outer class $inner class. This is what JVM understands. This is what's written in the bytecode. This is what's been hard coded. So JVM doesn't understand wheel. For JVM, there is no class called wheel. It's an outer class. It's the package hierarchy, fully qualified name of the outer class $inner class. All right. All right. So this is how we, and then again, the static type, sometimes it makes sense that you enclose your type like wheel inside the class that this wheel is tightly related to, or sometimes it just makes sense to create a package called car, and then each part of the car gets its own freestanding class. It depends on you and how you want to organize your project, right? The other thing that I want to mention is that, okay, what's the deal if we can just directly instantiate this static inner class? What's the point of putting inside the scope of the other class, besides the fact that that gives a hint that, for example, this type is directly tied to the outside type, right? If we say car.wheel, it makes sense that it means that this wheel, it can only be used with the car because it's the close relation. But there is a other benefit, is that a static inner class can access the static state, of the outer class, which makes sense, right? Non-static inner class could access the non-static state method, and it can actually access the static state as well, right? So non-static inner class can access like the full state. a static or an instance state of the outer class. But then if a class is static, it can only access the static part of the outer class, right? That's the only limitation, which makes sense. All right, I hope you enjoyed this lecture. We will continue this discussion, so please stay tuned, and I'll see you in the next one.